Welcome to the session number 1 of mechatronics. Subject code is 17ME753 for 7th semester mechanical engineering students. That is module number 4, that is related to mechanical actuation and electrical actuation system. In this, the main course objectives are understand the evolution and development of mechatronics as a discipline, substantiate the need for interdisciplinary study in technology education, understand the applications of microprocessors in various systems and to know the functions of each element, demonstrate the integration philosophy in view of mechatronics technology. In main course objectives is to understand the concepts and working of mechanical actuation systems as well as electrical actuation systems. After studying the entire mechanical actuation systems and electrical actuation systems, the students will understand the main course outcomes are understand the concept and working of mechanical and electrical actuation systems, learn the various types of mechanisms and switches, know the concept and working of motors. In mechanical actuation systems, we will study different mechanical systems, these types of motions, cams, gear trains, ratchet and pole, belt and chain trains, and then mechanical aspects of motor selection. In electrical actuation systems, we discuss about electrical systems, mechanical switches, solenoids, relays, DC as well as AC motors, principle of stepper motors and servo motors. Mechanical systems. Mechanical systems is a devices which can be considered to be motion converters, in that they transform motion from one form to some another form or required form. Examples will take transform linear motion into rotational motion and then vice versa. A linear reciprocating motion into rotary motion. Mechanical elements can include the use of linkages, cams, gears, rack and pinion, chains and belt drives, etc. Examples will take in rack and pinion can be used to convert rotational motion to linear motion. Many of the options which previously were obtained by the use of mechanisms, and nowadays there are advanced one, and then using microprocessors. Mechatronics approach by the use of microprocessor systems. Again, the types of motion. The motion of an object shows its changing position, but varying objects show various types of motions. For example, a fan is said to be a motion through its static in its place, or a hanging clock that shows motion through it is hanging in its position. We say that the motion is mainly of these are the main types of motions, that is rectilinear motion, circular motion and periodic motion. We'll discuss one by one. First we'll take rectilinear motion. In a rectilinear motion, all the objects move along a single line. Some common examples of rectilinear motions are marching soldiers, moving cars and moving animals. The common thing in all these examples is that they move in a single line. Next we will take second type is circular motion. Some objects are moving even though they are fixed at some position. Here the fan undergoes circular motion. In a circular motion, the objects follow a circular path of motion without changing their position. It is the circular movement of fan that results in cool air. Some more examples of circular motion are the motion of a Ferri wheel, satellite and rotation of planets around the sun, etc. Last types of motion is periodic motion. In periodic motion, physically the pendulum is not moving. It is fixed to some point, yet it shows the motion. This kind of motion that repeats after a specific period of time is known as a periodic motion. In a periodic motion, the movement made by these objects is called oscillation. Since it appears after a fixed period of time, it is named so. Clocks and table fans are the most common examples of this periodic motion. Some other examples of periodic motions are the child's motion on swings, the motion of the earth around the sun, the motion of the moon around the earth, etc. Next we'll go for cams, gear trains, ratchet and pawl mechanisms, and belt as well as different types of chain drives. First we'll take cams. Cams are mechanical devices which are used to generate curvilinear or irregular motion of mechanical elements. They are used to convert rotary motion into oscillatory motion or oscillatory motion into rotary motion. There are two links, namely the cam itself, which acts as an input member. The other link that acts as an output member is called the follower. This is the entire portion is nothing but a cam, and this portion is nothing but a follower. The cam transmits the motion to the follower by direct contact. In a cam follower pair, the cam usually rotates while the follower translates or oscillates. The complicated output motion, which are otherwise difficult to achieve, can easily be produced with the help of this type of cams. Cams are widely used in internal combustion engines, machine tools, printing control mechanisms, textile weaving industries, and automated machines, etc. Here, as shown in the sketch, it is a simple cam mechanism. As shown in sketch, a driver member known as the cam and a driven member is called the follower, and the frame which supports the cam and the guide is nothing but the follower, guides the follower. Next we'll go for classification of cams. Again, these cams are classified into three main types: wedge and flat cams, plate cam, and cylindrical cam. We'll discuss one by one. First we'll take wedge and flat cams. A wedge cam has a wedge of specified contour and has translatory motion. The follower can either translate or oscillate. A spring is used to maintain the contact between the cam and the follower. Here the figure shows wedge cam. This is a typical arrangement of wedge cam, and then this is the cam, this is the wedge shape, and then this is the movement in translatory motion, and then this is the follower you using. And then second type will take plate cam. In plate cam, in this type of cams, the follower moves in a uh, radial direction from the center of rotation of the cam. There are also known as radial or disc cam. The follower reciprocates or oscillates in a plane normal to this cam axis. The cams are very popular due to their simplicity as well as compactness. These plate cams are very useful as compared to other cams because of simplicity as well as compactness. And then last type of the cams is nothing but cylindrical cam. Here, as the figure shows, here a cylinder is a circumferential contour cut in the surface, and the cam rotates about its axis as shown in the sketch. Here the follower motion is either oscillatory or reciprocating type. These cams also called drum as well as barrel cams. Next we'll go for classification of followers. Followers can be classified based on again is classified into three main types. Types of surface contact between cam and the follower, and then type of follower motion, and then line of motion of followers. We'll discuss one by one. First we will take classification based on type of surface contact between cam and follower. Here types of follower based on the contact. It is 4 sketches are shown here in this, and then in this first sketch with knife edge follower, another one is with roller follower, with plate type follower, and then spherical follower. I will discuss one by one. First we will take knife edge follower. Here as the edge of the follower is like sharp, that's why it is called knife. The contacting end of the follower is a sharp knife edge. A sliding motion exists between the contacting cam and the follower surface. It is rarely used in practice because the small area of contacting surface results in excessive wear, because the sharp end, that is like a knife. Next one is roller follower. It consists of a cylindrical roller. The end of this follower is a roller type, which rolls on cam surface. There is a cam and the surface on which its follower will be rolls. Because of the rolling motion between the contacting surfaces, the rate of wear is reduced in comparison with knife edge follower. The roller followers are extensively used where more space is available, such as gas and oil engines. Next we will go for flat plate type follower. Here as the name indicates, flat means follower at the end of this follower, flat type. The follower face is perfectly flat. It experiences a side thrust due to the friction between contact surfaces of follower and cam. And then in last type, spherical face follower. The contacting end of the follower is of spherical shape, which overcomes the drawback of side thrust as experiences by flat face follower. Next we'll go for classification based on follower motion. In follower motion again classified into two types, oscillating type as well as translating follower. In oscillator, as is shown in figure A, In oscillatory followers, in this configuration, the rotary motion of the cam is converted into predetermined oscillatory motion of the follower as shown in sketch. And then in translatory follower, there is also called a reciprocating follower. The follower reciprocates in the guide as the cam rotates uniformly as shown in sketch. And then classification of follower based on line of motion. Again, it's classified into two types. The first one is radial, another one is offset follower. In radial follower, the line of movement of the follower passes through the center of the cam shaft as shown in this sketch. And then in offset followers, the line of movement of the follower is offset, that is some distance from the center of the cam shaft as shown in figure B. Again, the force closed cam follower system. In this type of cam follower system, an external force is needed. There is a spring releasing and then there is a follower, and then you can require some external force to maintain the contact between cam and follower. You have to maintain the contacts between this cam as well as follower. You have to require some external force. Generally, a spring maintains the contact between the two elements. The follower can be a oscillatory type or translatory type. And then this form closed cam follower system. In this closed cam follower system, in this system, a slot, here the slot is shown in the here, or a groove profile is cut in the cam. A roller fit in the slot and follows the groove profile. These kind of systems do not require a spring. These are extensively used in machine tools and in machinery. The follower can be a translatory type or oscillatory type. And then this is the three-dimensional cam, is also called comoid. Here as shown in sketch, the comoid is a combination of radial and axial cams. It has three-dimensional surface and 2 degrees of freedom. Two inputs are rotation of the cam about its axis and translation of the cam along its axis. The follower motion is based on both the inputs as shown in the sketch. And next we'll go for application of cams. Cams are widely used in automation of machinery, gear cutting machines, screw machines, printing press, textile industries, automobile engine valves, tool changers in machine centers, conveyors, pallet changers, sliding fork in a warehouse, etc. Cams are also used in IC engines to operate inlet valves and exhaust valves. And then cam in automatic lathes also you can use. And then automatic copying machine. Cams in automatic lathes. The camshaft is driven by a motor. The cutting tool mounted on the transfer slide travels to desired depth and at desired feed rate by a set of plate cam mounted on the camshaft. The bar feeding through its stock at desired feed rate is carried out by a set of plate cams mounted on the camshaft. Here figure shows the automatic copying machine. Here this is the cam and then this is the follower and this is the roller. and then the cam profile can be transformed onto the workpiece by using a roller follower as shown in figure. The follower can be mounted with a cutting tool. As the cam transfers, the roller follows the cam profile. The required feature can be copied onto the workpiece by the movement of follower over the cam profile. Next we'll go for ratchet and pawl mechanism. Here the figure shows ratchet and pawl mechanisms. This is the center one is nothing but a table spindle, and then this entire sketch is nothing but a ratchet, and then this portion next is nothing but a pawl. By using a spring it can be operated, and then this is the driven as well as driving pole, two poles, and then this is the arm. A ratchet is a device that allows linear or rotary motion in only one direction. Excuse me. As shown in sketch, it is used rotary machines to index air-operated indexing tables. Ratchets consists of a gear wheel and a pivoting spring-loaded pole that engages the teeth. These are nothing but different teeth. The teeth or the pole are at an angle so that when the teeth are moving in one direction, the pole slides between the teeth. The spring forces the pole back into the depression between the next teeth. The ratchet and pole are not mechanically interlocked, hence easy to set up. The table may be over travel if the table is heavy when they are disengaged. And then maintenance of this ratchet and pole mechanisms is very easy as compared to other mechanisms. Next we'll go for rack and pinion mechanism. As shown in the sketch, this is the rack, entire apparatus is nothing but a rack, and then this is the pinion. By using piston we can operate this rack, and then the rear adjustable strap is there, and then here spindle table. Here rack and pinion gear arrangement usually converts rotary motion from a pinion to linear motion of the rack. But in indexing mechanism, the reverse case holds true. The device uses a piston to drive the rack, which causes the pinion gear and attached indexing table to rotate. A clutch is used to provide rotation in the desired direction. The mechanism is used but is not considered suitable for higher speed of rotation. That is the only drawback of this rack and pinion mechanisms. Next we will go for Geneva mechanism. In Geneva mechanisms is also commonly called a Maltese plus mechanisms. The Geneva mechanism translates a continuous rotation into an intermittent rotary motion. The rotating drive wheel has a pin that reaches into a slot of driven wheel. The drive wheel also has a raised circular blocking disc that locks the driven wheel in a position between the steps. These are three basic types of Geneva motion mechanisms, namely external, internal, and spherical. The spherical Geneva mechanisms were very rarely used. In the simplest form, the driven wheel has 4 slots, as shown in the sketch is 4 slots, and hence for each rotation of the drive wheel, is advances by one step of 90 degree. If the driven wheel has n slots, it advances 360 degree by n per full rotation of the drive wheel. And then Geneva mechanisms can be used for light as well as heavy duty applications. Generally, they are used in assembly machines. And then these types of Geneva mechanisms and then basically required for in packaging, assembly operations, stamping, embossing operations in manufacturing automation. Next, CAM mechanism. CAM mechanism is one of the accurate and reliable method of indexing. It is widely used in industry despite the fact that cost is relatively high compared to alternative mechanisms. The cam can be designed to give a variety of velocity and dwell characteristics. The follower of the cams used in indexing mechanism as a unidirectional rotary motion rather than accelerating rotary motion, which is usually the case of axial cams. The cam surface geometry is more complicated in a crossover indexing type of cams. This is the one type of crossover indexing type of cam mechanisms as shown in the sketch. Thanks for patience hearing. And then for this these are the books I referred: Mechatronics by HMT, this is Tata McGrail edition, and then another one is Bolton, Pearson Education. And then apart from that, these two reference books, I am also referred Mechatronics by H.D. Ramchandran. And then these are the multiple choice questions for this session. The size of cam depends upon base circle, pitch curve, pitch circle, and then prime circle. The size of the cam depends mainly upon the base circle. And the angle between the direction of the follower motion and a normal to the pitch curve is called the pressure angle. In a radial cam, the follower moves in a direction perpendicular to the cam axis. And then which of the following conditions can be used to minimize undercutting in cam and follower mechanism, and then by using internal cams. Which of the following statements is false for simple harmonic motion follower motion? In this the acceleration is 0 at the beginning and the end of the each stroke. Which motion of the follower is best for high speed cams and cyclical motion followers? Cam angle is defined as the angle of rotation of the cam for a defined displacement of the follower. For HSM cam, the acceleration of the follower at the ends of the stroke and aimed stroke respectively is maximum and 0. The cam follower generally used in aircraft engines is roller follower. Cylindrical cams can be classified as reciprocating. And then thanks for patience hearing. And then also thanks LMS coordinator for mechanical engineering, Dr. Pundrika, principal, Government Engineering College, Ramnagara, and then myself, moderator as well as convener, Muniraju. Next, Government Engineering College, Chamarajanagar, along with Professor Vasant Kumar, Department of Mechanical Engineering, Government Engineering College, Kushal Nagar, and then Professor Nagaraj Buseri, Government Engineering College, Raichur, and then Professor Chetan K.S., Department of Mechanical Engineering, Government Engineering College, Chamarajanagar. Nagaraj Buseri as well as Chetan K.S. These two are the guest faculties. Thank you.